Hello, everyone. This is Jordi from Agents at Work, and today we have the pleasure to be meeting Johno from Answer.AI. Hi, Johno.
Hello, everyone.
How are you doing today?
Yeah, really good to be here.
I am really interested. I read one of your posts about AI agents and how AI may play, and I really like because you are one of the few people that say guys, let me expose some facts, and then tell you at the end it may play this way or this other one, but I don't know. There is still things that need to develop. So I was really, really happy to bring you in the podcast to talk about that.
Yeah, it's funny. I feel like that's in many ways kind of the only reasonable position at the moment is to have these very wide error bars. And I should be clear, the post you're referencing is just basically me piggybacking on a fantastic one by Nicholas Carlini that says basically the same things. But yeah, I'm excited to be here and talk about it anyway. I know, so our mutual friend Paul was basically asked me to come on because I'd been somewhat skeptical of quote unquote agents. But then it's funny because it's like, oh, it's, you know, I'm also coming around a little bit on something. So there's even there's some I always say like my distribution is bimodal. Like I think it's very exciting and I also think there's a lot of hype. So yeah, lots of uncertainty, but kind of excited to dig in.
Okay, so for giving a bit of context, what's your background?
Yeah, so my background is well historically like engineering and then data science and then slowly going into deep learning. And then yeah, probably like I don't know, 3 or 4 years ago now, started getting more into like the early days of the generative AI and using that as a way to teach people machine learning. I'm very excited about teaching. And so then I ended up running a few courses on diffusion models when those were becoming like a thing. And that led to working with Jeremy Howard, then at FastAI. And then we kind of started a company called Answer.AI beginning of last year. And so now we work on applying AI, trying to find beneficial and useful applications that yeah, are positive, but that we can also like build and make some money off of.
Okay, and we are living in a time where the definition of an AI agent is something fluid. So for
Mhm.
someone with your background, when we discuss here about AI agents, what would you call an AI agent?
So I really like the distinction that's laid out very clearly in a post by Anthropic, where they separate workflows and agents. So you can have a very general definition of an agent, anything that affects its environment, but then that includes everything from a chatbot to a single prompt with structured outputs, all the way through to the like crazy chains of nested sub-agents that people do. So the distinction that I like, yeah, those are all technically agents, but when I talk about an agent, it's something where the model itself dictates what the program flow looks like. So it's not just like, oh, I take in a document, I summarize it, and that's it. It's not even like I take in 3 documents, I summarize them, I summarize the summaries, and then I put it out. That's all still very deterministic. Whereas an agent might be like, oh, I browse to a web page, right? I choose to read another link. So then instead of returning, we're taking another action. And then I choose to read 2 more links, and then I summarize those, and then I go and look up in a database. So there's like some sort of program flow that might be different every query or every run. And in the middle of that is the model choosing one way or the other.
Would you say that it's only for choosing, like going left or right, or it should actually create like the action flow? So it should, if this was a graph, it's not only
Mm.
about what edges it should follow, also the vertices should, just spawn, for example. There is no, okay, should I now follow another HTML page or not, or link? But instead, because I think that it's useful, let's create an edge that goes to read a new page.
Right. Yeah. I think anything that's changing that structure, right? So that could be even just a loop. So I've seen the shorthand of, oh, an agent is a language model with tools in a loop. Like that's great, right? Because the number of times the loop runs and what happens, which tools are called each one, that's already a very flexible structure. So yeah, I definitely say that's all falling under this umbrella of agents.
Okay, nice. And what's your relation with agents right now? Like, are you using any of them? Are you seeing them spawn out there? Are you seeing things that are not agents being called agents?
So, I mean, lots of that, right? Lots of agent branding at the moment because this is something that suddenly everyone's very excited about. I know people who, they started working on agents last year and it was like this niche thing. Don't talk publicly about that. You're at Microsoft or whatever. Look, we're excited about this, but just keep it on the down low. And suddenly they're like thrust to the fore. Like, look, everyone, we have agent frameworks. So yeah, it's very exciting. We are somewhat less all in on that. In general, the philosophy of Answer AI is very much trying not to follow the hype, trying to do our own thing, trying to go from first principles. And you'll see as there's a few different topics you mentioned discussing, like there's some ideological places where we're very much trying to go, okay, what is the human in control doing things very thoughtfully in small steps? And a lot of the agent framing is human handing off control and doing very large steps. So we do some things that would fall under the definition I just gave, right? And search is the perfect example. Search and research, a classic case where being able to have the language model execute one or more steps until it comes back with an adequate result. Like that's something that, yeah, it's kind of like obviously amazing. And we have some internal tooling where we also have, yeah, this idea of like, maybe another one is file editing, very similar to Claude Code or something like that. Yeah, you can read the file, maybe it chooses to read a few other files, right? Or chasing function definitions down to say, okay, this is calling that function. Let me go read that source code. Okay, it's calling another. Just using this sort of Python inspect machinery, anything of that sort of nature. Yeah, this multi-step agent style is very useful. But in general, our approach is like, okay, how do I make it not an agent? How do I make it very explicit and small and piece by piece? Yeah. So
And you said that before you did machine learning, and you go like 4 years ago, like started like moving more into what now it's Answer AI, or led you to Answer AI. What things have you seen that really change in the environment? Like, what would you say that it's a breakthrough that makes us having this conversation today and not in 2021?
So I think the big difference is the initial wave when I was getting into deep learning was like, oh, this is something that's now suddenly genuinely useful for specific use cases, right? So I mean, I did the FastAI course, so I was very excited about ULM fit training LSTMs, and then transformers were out, so like training BERT. If you had a specific task in mind, right, I need to categorize these kinds of inputs into these buckets, and I have lots of training data. I have 100,000 rows carefully labeled, then you could do amazing things with AI. But it required a lot of expertise, and it required a lot of time and a lot of specified data. And the difference now is the generality, right? You can have one model that can take in an image and classify it, or it can summarize a document, or it can call arbitrary tools to classify things. It can, somewhat arbitrarily transform text into other text, reason across, sequences of actions. So suddenly you have something where instead of having to go and build a data set and train a model and all those things, you can just specify in English, hey, I would like you to read this document, and then if it's on a medical theme, copy it into this folder and then send me an email. Like you can just very, very easily for an average person or any developer, you can specify behavior. So I think that's the key difference, is that it's suddenly very accessible and easy to do a huge swathe of tasks.
And for someone who was working into this, was this expected? Like it was like, well, yeah, in 2 years this is gonna happen, or it took everyone by surprise?
I mean, it took me by surprise. I won't claim to be prescient, right? You saw hints of this. There was this model called Flan, that was like, oh, rather than having to fine tune a new head if you want to do classification versus translation or any of these sort of old school NLP tasks, they had just like generic text to text. And so I was like, oh, wow, I could do all kinds of, like all 5 NLP tasks, like that was like, wow, we really broad. And so, yeah, I didn't think then like, oh, I need to extrapolate this and realize that this will keep going. But so I guess I always thought it would keep getting easier, but I still kind of pictured in my head like the FastAI library will be so easy to use. Maybe it'll be point and click, and the data set builds itself iteratively with you. It was like, oh no, you don't need a data set. that wasn't on my radar back then.
For me, I always ask this question because for me it was digital more than analogic. So it was a zero, and out of the blue it was a one. Like the signal was literally like, well, yeah, this is AI thing. I see cameras that put like some squares with different colors and try to tag like this is a person, this is a car. Not interested there. Paul, even back at university in 2012, like he was really, really into machine learning. He was telling me, was not impressed. Like for me, I was like, well, yeah, it tells me if it's a cat or not. Good. Then like AlphaGo happened. Still like, okay, yeah. Like I really like history of computing, so I was like, yeah, Deep Blue, sorry. Also like destroy Kasparov in playing chess in 1996. So it's okay. Like I see it as expected. And then one day, I don't remember exactly when, but I think it was November of 2022. I go to my browser and I speak to machine and it replies. And I was like, what the hell is going on here? And it was generated. So it's something curious because I told with many people who were into machine learning, and even for them, they told me like, yeah. It was like an inflection point. Like we were like, yeah, these things are getting better, but it's not like it was under your radar and then it crossed some line. It was like really like a sigmoid function. Like it went from we are doing some stuff to what the hell, like this thing is really generalizes. And then all the capital and brain power joined the revolution. So I would expect it to, like go more and more. And I am one of those that decided to join here. So right now in Answer.AI, for people who don't know this, if you're into AI, you know what Answer.AI is. If you are not, like if you're just listening this for first time because you're interested into AI agents and things like that, I will try to summarize it and then we can go into depth on what you truly do there. I think that in your page, it says something as a practical AI research lab. I know that Jeremy may think that this is too big, but what I would say is like, if the good parts of Bell Labs were moved into 2025 in the AI era, so that's what I think that you're doing there, guys. Like it's amazing. Like you are such a small team producing like incredible research, and we'll go into it. But it's amazing because it's not only theoretical research. Like you have things like Mother Bird that we will discuss. That it's mind blowing. Like it's just like, well, we can just do this with encoders now. But then you have things like FastHTML, LLMs.txt, and many more things that we will go into it with the podcast. But for you, how was joining that company? Like, what attracted you to them? Like, how did you discover them and then join?
So the story, I guess, is that after we'd done this course on diffusion models, the FastAI Part 2, very long, very in-depth AI research course. And then there was this kind of odd feeling because it's like, okay, I'm teaching people how to do research the way I know how to do it, right? Like old school training models, small scale experiments. But it's kind of hard to ignore the fact that like there's this big thing happening in the world. There's a lot more attention coming to AI. There's a lot of like, even then, like lobbying that look, open source AI shouldn't be a thing. So there's a lot of like potential for concentration of power. There's a lot of like FUD around we're going to die tomorrow or this is a fad. It's like, okay, we should do something, right? What should that be? And so I think Jeremy had started speaking to a lot of people, economists and philosophers and everyone in between, like what is this trend going to bring and what should we do about it to try and make that positive? And at one stage it was like, maybe this will be like policy discussions or something. But then it became kind of clear, like, no, I think that one of the big tricks is going to be to work with the technology and especially like focus on, we did a lot of stuff on like efficient inference, making the most out of existing models and open source models, focus on these kinds of things that would make sure that the technology is broadly applicable and useful to everyone, not just like only concentrated in a few application providers and no one else gets to play with it. So that was some of the initial thinking. Yeah, and then very much like the idea that Jeremy then came back with was like, hey, potentially got some funding. And this is, yeah, something like Bell Labs or like, the early like General Electric. It's a research and development company. So we want to be like playing with this new technology that we don't think anyone knows what it's good for yet. Like doing lots and lots of experiments, putting them out there into the world, starting to get a signal for what works and what doesn't, and then hopefully over time, over many years, building out lots and lots of useful applications based on those learnings.
I am really impressed with the production that the team already had. Like you're like an A+ team, like really small team distributed around the world, and then putting out like incredible research and incredible like practical applications of it. This is something that really got my attention about AI that did not happen with things like distributed systems. So at some point, like the best way to be into research was you join one of the biggest organizations in the world, like Google, Facebook, Microsoft. And then you say like, okay, so how do you do things here? And then out of the blue, you're like the best researchers in the world because this cannot be replicated at a small university. Like even if you're at Stanford, unless you do some collaboration, there is not much that you can do there. But play with fundamental ideas. Like if you're into operating systems, yes, you can do something that is small. But if you want to really know about operating systems, the best thing is to join Apple in 2008 for the iOS on phone, and then you are like, okay, yeah, like this is how you do compilers for this kind of new microchip. With AI, there is something there that it seems to allow small teams to bring efficiency to things that were supposed to be only for big companies. Why do you think that happens? Like, what's the thing that AI has that allows a small team to actually not even compete, but actually like put products out there like Modern Bird that is like top-notch research, and yeah, it has like some cost, but it's even like manageable for a small organization.
Yeah, I mean, maybe Modern Bet's a trickier example because that did require you just have to have some capital and compute and a lot of like research skill. Like the folks who worked on that really spent so much time, 10% improvement in speed, another 10%, another 10%, like, and that compounds. But more generally in AI, I think like one big difference that in general enables lots of small teams to have a lot of impact is that if you're a big enterprise company and you build traditional software, like a piece of traditional software, it has 18 features, right? And so a small startup could scoop you by spotting that you're missing the 19th feature or by making a cheaper version of those 18 features. But with AI, like, GPT-4 comes out, right? OpenAI doesn't have a list of the features it can do, and so they're limited by like, okay, it's almost this like alien artifact. How does this work? And we're not like product people necessarily, right? You're AI researchers or, GPU, fanners or whatever your role is. So a lot of people who have like their own unique problems, their own unique domain expertise, they can come in and say, hey, like, hey, nobody even knew that this thing is perfect at, back translating French medical records to create whatever. There's just like so many like infinite little possibilities. I think that's one of the biggest things. It's like, yeah, every small team can take these artifacts and they're not like deterministic artifacts that only do 5 things. They're very general. And so there's a lot of like discovery to be made there.
Okay, that's a really good insight. Like I didn't know like this was a genuine question, and it's this idea of the knowledge of the world is distributed in many people, and now we have a generic tool that then those people are seeing, and thanks to creativity, they are able to say like, wait a second, this tool is perfect for my problem, and most of the people don't even know that that problem exists or how big it is.
Mm-hmm.
So that's it. Okay, perfect. So it's good to know. Right now, when you join Answer AI, I think that you have been there for more than a year already.
Mm-hmm.
What kind of tasks do you do there? Like, how do you work with other people? What's your role?
I think so. Everyone at Answer AI is kind of a generalist, right? My job title is R&D. I think same as all of us. So that's something that's kind of unusual and kind of only really enabled by AI. So yeah, a lot of our focus has been. So we said you bring in someone with their expertise and they'll like see ways to do it that way. So we've got some tracks that are based on some specific piece of expertise, right? We have a co-founder who's really good at writing, and so he's got some ideas there around writing and research. We've got a partnership with some law experts, so we're the tech assistants for them, working out some like cool ways to apply it to those fields. But for us, a lot of what we're good for is like teaching and coding, right? We're all programmers, we're all developers, and also our mission is to build lots of useful applications. So what a lot of our initial focus has been like pointed at is yeah, using these models for those kinds of things, right? And so that means like some work's gone into hosting local models really efficiently on like cheap consumer GPUs versus having to rent H100s in the cloud. Some of that research has gone into like internal tooling for development and how do you develop with AI assistance very effectively, like our way. And we can talk about like notebook development and all that kind of thing. Some of it's been like, oh, we want to build thousands of web applications and we don't really like the existing stack that people have on offer, especially if we want to be in the comfort zone that we have of Python. Okay, let's make a new web application framework that's more ergonomic and it's going to help us scale out and test these ideas quickly versus getting stuck, configuring some file that we don't understand. So it's a very, very like adventurous and exploratory way of working. But yeah, it's been a really fun journey exploring those different rabbit holes, and I think there's been some cool things that have already come out, and hopefully lots more that'll start to compound as once you've got all the pieces, they start clicking together, and it's just starting to feel like that. Like, oh, finally, this momentum's building, and these pieces are coming together.
Yeah, I can feel the acceleration. Something that I would like to go into that you just mentioned, it's this idea of the method. Like the method seems to be
Mm-hmm.
like really important in how Answer AI like it's able to be so productive. And it's not only like the way of thinking, but actually like the way of developing. For sure, it's everything like you are like really like top-notch researchers. You think from first principles, but on top of that, you are able to iterate really fast. And one of the things that Jeremy is really famous for is his big push for notebook-driven development. Could you speak about this a bit and actually the name that you already dropped that it's NBDev?
Right. So, I mean, NBDev's an idea that Jeremy's been working away at with a few other adherents for a long time. And the idea is just that it's somewhat archaic, right? That at the moment you think about your software, and then maybe you have a plan or a design document or something. And then in many separate files on disk, you put the code, but somewhere else entirely, you test that code, right? And hopefully at the end of it, if you're lucky, you get around to writing some documentation. And we know like that final step almost never happens. And so the notebook driven development is like more generally pushing at this idea of like, what if it was all in one place, in one way, right? So like starting out, this is what I want to do. I'm working on pieces, and as those pieces are built up, they're tested and they're documented, and you can see what's happening. And so you end up with this like almost like a conversation or a record that if someone else gives you this notebook, you can see what's going on. You've got the documentation, you've got the outputs, you've got the tests, everything's integrated. And it turns out that if you develop software that way, carefully, you can avoid a lot of bugs, right? You can do it really well the first time. You end up with something quite maintainable. The problem is that, there's also lots of downsides of notebooks. There's lots of critiques that people have drawn, and there's lots of questions for like, okay, now that AI is in the picture, what does that happen? So we still like exploring that avenue. I think it's a very rich vein to mine, and it goes quite counter to the vibe coding, offload your coding entirely. But there's actually quite a lot of similarities, right? Because you're still wanting to say like, well, what actually defines my software? It's not just the raw code, and it was never the raw code. It's like the intent and the plan and the pieces, and then the putting the pieces together carefully in the architecture. And maybe that happens in your like Claude.md file, and the AI still writes the code. But it's really nice if you do it our way. It's really nice to see how actually you can also just have the code there as well. If your libraries are clever and ergonomic, it's not even a lot of code usually. The AI can see that context, and it's not just looking at your code, it also sees your intent and your tests and your explorations. And so it's very, very useful in that context. Yeah, so it's a strange and interesting way of developing software, and it applies better in some cases than others. But for a lot of what we do, like experiments of what AI is good for, it's fantastic. And I think it's one of the main reasons we can try things so fast.
I think that there is something fundamental that it's like orthogonal. So it's not only that it applies to some specific use cases better than others, but also to some people. Like I have seen
Hmm.
it click. Like for me, most of the time, I build things top down. So I think about what the big thing is going to do, and then I just write it, and it's not working now. So there is nothing to execute there because it's a
Mhm.
promise. Like in the future, this is going to work. And
Right.
then I keep doing stuff, and at the end, I just put the last piece, and out of the blue, like the light blobs up. Okay, like now the full circuit it's done. However, like with notebooks, like most of the people are using them, like when it works well, like starting with the small pieces, say like this piece is well developed, it works, and I already know where I'm going to use it. And then you have this kind of conversation that I haven't seen before. And now that I have seen it, I am a big believer because, for example, with Paul, like the colleague that you already know, I have seen him totally change his productivity by saying like, wow, this is so much better. And he's even happier. So I think that it's not only the problem, but also the people that they try it and it just clicks. So it's something that it's really, really nice to see. And it's something that software development has forgotten since ever. So this is something like in a small talk. Like people that are doing Lisp, they were like, well, yeah, this is environment. The code is the environment. Like it's already running, you're able to play. And then out of the blue, I don't know what happened. We started compiling stuff and then we're like, okay, so totally different. You just have the source code, you need to compile it or to execute it, and it happens somewhere else. And then we had to build things like test-driven development and things like that, only to solve these flaws. And I think that there is not one winner versus one loser,
Hmm.
but it was curious for me to see that it was totally forgotten. And then I think that you're a really good example of how this can work, and it really gets the attention of other people. Like people are looking and say, like, how are they so efficient or so productive? And MVDev is the tool that I will make sure that the link is in the notes because anyone should try this. It's not only this development; it helps you with pushing the package already. It helps you with the documentation. Like most of the stuff that usually is a headache for
Hmm.
developers, out of the blue, it's like fully integrated. It's like a vertical solution for software development, which is I haven't seen. So it's really really cool there. And what you mentioned about AI agents, what is this thing? Like you use AI while developing with notebooks? Is it a good fit, or do you see like some challenges there?
Yeah, well, okay, I want to go. There's a couple of things I want to mention from what you just said before I dive into that. One was like, oh, it's obviously just clicks for some people. Like, it's a lot of work, and I think like that's maybe a misconception. It's like, oh, it must just work for Jeremy. It's like, no, he spent many decades doing this. It must just work for Johno. Even Paul, like we ran a course, and your initial instinct is so powerful. To like, I can see the solution. Let me just write it. The other was you said, oh, this like you get this nice sequence of steps. Often that's the final result, but I think you also like you do still start by imagining the plan and coming up with if in an ideal case these functions would exist and then it would be able to go like this and then you can build it up. But that's all practice and that's all like forcing your brain to work in a slightly different way. Okay, so now to like how does AI play into that? It turns out that it plays really fantastically in a lot of cases, right? Because yeah, like I said, if you're if you just have some code and you're trying to debug it, especially like say it's a machine learning experiment or something, that's one set of inputs that you can share with the model, right? And you can manually add more stuff to the context, right? You can say, look, here's a screenshot of my latest run. Here's the schema of the data, but that's a lot of effort to add. If you're in a kind of exploratory notebook or something similar, um, and the AI can see all of that, you have a complete shared context, right? So I can see the plots, the AI can see the plots. I can see that the table, the AI can see the table. And so then when I say, could you like plot the date, but it's actually called like date start, you're not having to say like, by the way, like go read the CSV file. It's just there because to like I need it to work and the AI needs it to work. And if it was in a separate context, maybe I'd miss putting it in there. So it's actually it's an incredibly powerful pairing. It's not always ideal, right? Like we're doing a lot of web development, and web development and notebooks pair slightly strangely. And so there's cases where like maybe you don't need it for that, right? Like maybe the best way to code a website is to code a bad website first and then look at it and then make visual changes. And then you can ask the AI, like, hey, change this HTML. And it's seen enough HTML. It doesn't need any extra context and it can take a screenshot. You know, there's lots of other ways of working too. But for the kind of like exploratory, experimental, incremental development that we do, having the AI in the notebook or in that kind of environment, yeah, it feels kind of like a superpower.
And usually, how it is for AI, because for me it was surprising. Like most of the people ask the AI to code in a way that they clearly don't code that way, and
Mm.
then the AI hits the same blockers that they do. So, for example, they say like, "So here is a sheet of paper. Write me the perfect program that does X." So in reality, like if you ask me that, I would fail like 10 out of 10 times. Because what I do is like, okay, let me get with something that more or less works. Then I have to bring documentation of libraries
Mm-hmm.
that I am using. I have to check, like I don't remember all the libraries or how they are even used, like what's the patterns there, or if they are good match. So I need to explore a bit with it. And then also, even after that, it's not just about reading and then writing, I need to execute it. I execute it, and that's what gives me the knowledge of what's missing. Then with AI, like people seem to forget about this and say like, okay, I use a big model and I say like, just do everything. It fails, and it's like, well, this doesn't work. It just
It's really
fails.
bad. But yeah, that's a really good point, right? Like, and the structure of these files is often it's crazy because you write the imports first and then you don't even know what you're doing, or you write like some people ask it to write git diffs, and like the format will be like the number of lines changed is the first like few tokens it generates. It's like I can't tell you how many lines of code I'm about to write before I've written it. And this is one case where I think actually like the move towards agents and away from like a single flow actually makes sense, right? So like yeah, asking GPT 4.5 in the chat UI, say, hey, write me this perfect program, versus something like even Claude Code, where it's like, okay, make a minimum program that just prints out so you know the environment set. Oh, you need to install a library, run that, rerun it, you know, like have this kind of loop, see the outputs, then add some more imports and add your first function, you know. But you can see like it already starts to sound like what we were talking about in the notebook, right? You instead of writing the whole thing, it's like, oh, do a piece, check that piece, do another piece, check that piece. And it's kind of tricky because all of the training at the moment is like produce the perfect output so that you get the human feedback, you know, the positive human feedback. So that very much biases it towards like, here's this wall of text that does everything and a few extra things that you didn't even ask for. And so, yeah, like I'm hopeful as long as we don't just like throw that at the wall and hope that that's the way, I'm hoping that there's this change of like, okay, if we're allowed to do multi-step agents now, please can we like make the steps smaller and have that feedback and have the human in the loop as well, and then suddenly it starts to feel more like tractable to do software development with AI.
Yeah. For me, that was like a really easy insight, like something that I saw since the beginning. But I think that for the community to care as a whole, like we need like one of the big labs to put it a name. So the same thing that they did inference time training, this idea of oh,
Mm.
okay, no, like now we let it think. They're like, yeah, of course. Like if you make more tokens, it's able to have more context. And then eventually they will say like, listen, this is not only about at inference time more tokens. If you are able to interact with the thing and then like receive the feedback out of the blue, the model knows more stuff, and you're like, yeah, of course, but we need like a fancy name for it since in machine learning.
Yeah, I mean, maybe. You know, this stuff doesn't have to wait for the big labs, right? It could just be a practice that we all start adopting. We say, hey, like just ask the model, show me just one change, right? Like, or ask it for small pieces. Ask it, you like teach people, like, hey, you can just ask for tests, right? Or you can say, like, do a mock thing for now and let's test it with that. Like, all these kinds of approaches that software developers kind of already know, but yeah, reinforcing that and building that norm. And if that's what people want, then And you can kind of already see this pushback, right? Like Claude 3.7 versus 3.5, it's amazing for like it does everything itself. But I've seen some people saying, I don't like coding with this because I ask it to do something and it adds 5 features. And I actually just want it to do one small thing. So I'm hoping that voice kind of like sticks around and feeds back to the labs and also shows the way to say like, hey, there's productive ways to do this that aren't kind of, because everything's about replacement, right? Like if you're chasing AGI next year, you don't care because it doesn't make sense to write 5 lines of code at a time. It makes sense to write like the whole piece of software. And so, yeah, there's got to be some sort of like market thing that says, hey, in the meantime, instead of that, like this would be a really awesome tool if it worked with us as a co-pilot rather than as a replacement.
Yeah, for sure. I noticed that my cursor development flow now got like ADHD. Like I
Mm-hmm.
asked for something, and out of the blue, it's changing like some small comment that has nothing to do with the change. It's like, well, what is this? And it replies something like, well, it's an improvement. And I like, yeah, but we're not working on that. Please
Yeah.
focus. Which is curious for me because it seems like with transformers, like people understood like, well, attention is all you need. And now we are diverging to say like, well, actually, you can focus in 100 things at a time. It's like I said, please, like, can we make sure that we are following that trend? Because the only existence of intelligence that we have, it's the human one, the one that we know that it's generic enough to, or the most advanced that we know of. And I try to pattern matching a lot of stuff and flows. And it's like, okay, what happens with humans? And I try to do it in such a fundamental way that I say like, well, if we were half dumber, this would still apply. And if we were like double as intelligent, it could still apply. So even for people who are chasing AGI, this idea of it can do everything in one prompt, I try to push back because reality is that the more it can do, the more I'm going to ask for. So if it can do a small piece of software, then I'm going to ask for a whole program. If it can do a whole program, then I'm going to ask for a whole operating system. If it can do a whole operating system, I'm going to ask for logistics. So for example, like the project now is like we are terraforming Mars, do it. And it's able to do that. It's like, well, we want to travel through galaxies, so do it. So at some point, we need to have this idea of, well, there's not enough compute. Let's break it in smaller pieces and put them together. And I think that that's where like notebooks and things like that like can help quite a lot. But yeah, I know people that are trying to create this all powerful God that they imagine that they can do everything. I don't think that that's happening anytime soon. Even if we got AGI, like even if we have something that is as smart as a human for doing stuff, I think that we are going to run many of them, and then the knowledge gets distributed and happen the same thing that we were discussing about creativity. I was saying like, well, it happens that just because of how the knowledge is encoded in the universe, there are like different intelligence that have like different insights. So when they get the same piece of information, they're able to generate different things. The good thing of AI that it's really different from humans is that we're going to be able to clone them. So whatever works out of the blue, we don't need to communicate and actually change the weights of my brain from yours or the neuron connections will be for us. But we can actually say like, okay, let's spawn like Johno knows a lot about this. He's actually constrained of because of his hands. Let's create 100 Jonos. So we will see how that that plays out.
Yeah.
How do you see these things? Like this idea of having a really powerful AI versus many small one cooperating.
It's a good point that you raised that the even if it does get relatively smarter, the same sort of tools and designs that we put in now apply. Actually, like it makes me think a little bit like I should be reconsidering how we design things. Because one way to do it is just say what's the best model, and let me throw the biggest chunk I can at it. But maybe there's something to say like, look, maybe I should test on a kind of slightly dumber model, because then I'll realize like I actually forgot to feed it the docs. I should make more stuff available, and then it's going to do a better job, and that's going to help the smarter model too. Yeah, I like that. I like that a lot. I should just like make a mental note, like always test on like haiku, and then change the model. But yeah, more generally, like there's some other beyond just like big and small. There's some other axes that are worth talking about, and I think like one of the reasons Paul said I should come on was he said, "Oh, we're very pro agent, and I'd like a slightly different voice." The other framing, right, is to do with like replacement versus augmentation, like that kind of axis. So you were mentioning, like, oh, I'll just keep asking for bigger things, and at some point you're saying, colonize Mars, or okay, that was easy, like okay, colonize the whole, known universe. It feels like somewhere in there, it'd be kind of nice to have the human intervention, right? And so we've been thinking about where that boundary is, because for a while it felt like the best way to do it was to get the language model to write 5 lines of code, right? Or one tool. And we're starting to get to like some reliability threshold where it's actually useful to say like, look, go and do 5 minutes worth of work, right? Or 10 minutes. There's this lovely paper recently looking at just the time horizon and reliability for different time horizon tasks. And obviously it's not like perfect or guaranteed to apply everywhere, but even if that's the case, if the language model can do an hour's worth of work, I think as a designer of tools or as a user of things, it's worth saying like, well, that doesn't mean I have to, right? I don't have to use the largest available chunk. Maybe it's worth checking in, every time I want to edit a different file, right? Or every new feature, or I don't know what the unit is, but building it in a way that like the person working with it doesn't feel like, oh, that did my job. But instead is like, hey, look at what I'm building together. And so there's a lot of interaction design and thinking and space around there that I wish more people were thinking of, because that's one thing that worries me. It's like the focus is so relentlessly on what's the biggest task I can do, and then hey, look, I've got these amazing systems; they can do bigger and bigger things, and no one's stopping to think like, what are those things, and are they worth completely automating versus like having someone joyfully do them with an amazing tool. So anyway, that's a bit of a ramble, but to say like I like your question, but I also feel like big and small is one dimension, and there's lots of others that are useful to think about too.
Yeah, a couple of things that came to my mind was this idea about proving with smaller models or dumber models to
Mm-hmm.
make sure that the information is there. That's actually how we run our company. Like people try to explain me things and I am like the low barrier there. If I cannot get it, like it's like, okay, we need to dumb it a bit down. And then we're sure that the moment I get it, everyone in the company can understand it. So it's like a good measurement. It works with people. So I guess that it will with models too. And the second thing, it's this idea of I read the paper with like what kind of tasks for how long it can run. I was a bit suspicious of it because I was like, okay, so if it can run one for 5 minutes and then like it kind of breaks,
Mm-hmm.
why don't we stop it at 3 minutes and restart with a new agent? And it will do 5 minutes more, and we are able to like tight it forever. So what's what is making it stop at 5 minutes? Because after all, like time is a continuum. So you just say like, well, what happens if I just tell you that you started 4 minutes ago? Like out of the blue, you're able to continue doing. Like you just stop because it's five. And I think that here someone or some researcher that can be really useful. It's about information theory. I think that this
Mm-hmm.
should be analyzed on, okay, what is happening? What's the consistency that gets lost? It's because like we add too much information. It's because we don't have enough information. It's because we degrade. Like what is going on there? And I didn't see that in the paper. That was like the first thing that triggered me. When I saw that, I was like, well, if it's about 5 minutes, I'm going to tell the agent every time, like you have been working only for four. Please continue. And like you just like keep doing. So it has to be something fundamental there that it's different from the time. But it was really good on this idea of agency that people say like, well, no, it needs input each time, and it looks like no, like we are reaching the point where they are able to do things before they diverge. And I would focus on why they are diverging more than the time. Like the time can be a proxy.
Mm-hmm.
I'm saying like, well, maybe it's because after 5 minutes there is enough information that it diverges. So okay, let's focus on what's the thing about the encoded information versus the time.
Yeah.
But we will see how that plays. About being super pro AI agents, like I have this podcast exactly for that, no? Because I want to talk with more and more people and make sure that I get all the inputs that are interesting for the industry. Plus,
Mm.
it helps putting out information that many people don't know because they are working in silos. And as you said, like creativity here, it's really, really important. So there's a lot of ideas that they can be caught on, a random podcast that can do big things in reality. Jeremy is one of the voices in the space that I respect the most. And I was really surprised when he always, like, his position has been like, well, agents, I haven't really seen agents working. And for me, there is signal there. Like, whether, when he says something, I say, like,
Mm-hmm.
well, this is not a random guy that just went there and said, like, you know what? I don't feel like they are AI agents. And I really like because he has also like an open approach of when I see them, I will let you know, but I
Yeah.
will be able to. And I like a lot about your post when you say like, well, actually, like I also respect these voices, and for first time, I'm starting to see them happening. And I think that it made me happy because I said, well, I'm not the only one with this position. It's actually spreading in the world. What are the things that started, to click for you with this idea like, okay, maybe AI will be able to do things beyond. So we talk about an inflection
Hmm.
point when GPT came out, but then we kind of bounded it like, well, this is not for agents, just a generic tool. What is
Yeah.
changing that is making you rethink these principles?
So I think there's still a lot of ways where I feel like the promise of agents that run off and do lots and lots of arbitrary tasks for you is still not quite there. And part of the reasons is like, oh, the model capabilities, right? There's just some things that are still very, very difficult for them to do. But a lot of it's also just the systems around it, right? The types of feedback that they get, the types of information they can see. And so some of the things that I'm finally starting to see work, and the things that are making me like rethink how much software development could be done, for example, is just actually the tooling around it. So Claude Code is amazing, partly because, or take like Replit Agent. Replit Agent, the latest one v2, I think it is. It's amazing, partly because the model is amazing, right? Sonnet 3.7 is incredibly powerful model, very good at web development. But like that on itself isn't why it can build web apps. The reason it can do that is because they've also got this environment where if a package is missing, the model can see the error message and then it can edit the package.json or whatever, and then it can restart the server, and then it can take a screenshot. So the kind of like the model itself, you could say like, oh, the model can't build this web app. But the model in a system that's providing this feedback, that's having the user test things out, that's also able to use a computer and test things out, that's also reading files and seeing errors, like that whole like system becomes much larger than the model itself. And so it's really cool to see like a few cases now, finally people like doing that right, giving enough feedback, making things simple enough, not overcomplicating giant chains of self-referential, agent swarms and whatever else people were doing before. So seeing that is really nice. Yeah, for me, the other thing is just watching the like increased capacity that comes from the specifically RL training, as opposed to just supervised fine tuning on demonstrations. That's been like a bit of a surprise to me in terms of like absolute capabilities when you go from like these models can do a lot in one forward pass, right? Like there's a lovely recent interpretability work from Anthropic looking at like, oh, there's a bit of planning ahead and then backtracking a little bit, so forward and backwards planning, quote unquote, right? And that's all happening in one forward pass. But there's only so much you can do, right? There's like hard computational limits on the kinds of things you can do in 32 transformer layers. That goes out the window if you're allowed to do reasoning to yourself. And so O1, R1, O3, like these kind of like beyond just supervised fine tuning, there's like genuinely learning to do your own scratch pad and then getting a verifiable reward. And that feels like a way to push the capacity a lot further than I expected, say, last year. I expected we could always keep getting better, but the cost would be prohibitive and it wouldn't be much improvement. I thought there'd be like some sort of slowing down there. And the fact that so quickly this new paradigm's come up, yeah, I'm definitely rethinking a little bit like, okay, I still haven't changed my global thing that I'd like these to be tools rather than human replacements and whatnot. But the types of things that I assign to my tool is no longer just like write my imports for me. It's like make a demo app for this, and I really enjoy like having that at my fingertips, even if it hurts a little bit that it takes away my
Yeah.
skill.
Like we are literally living in the timeline where I thought that it was sci-fi, that you just ask the computer to create a web page for this podcast actually, and it's
Yeah.
how it was generated, and it's like nicer than anything that I could have done, and for sure in that time. Something that I am really interested on, like it's this idea of what are the fundamentals that like manage the universe and what can be applied for when there is a new thing happening. And with AI, what you said about reinforcement learning, I think that it's highly tied with something that I have seen many times. Like it looks different, but it's always the same pattern. It's this idea of I take something that it's not Turing complete, and follow me here.
Mm-hmm.
Something that it's not Turing complete, and I am able to do a Turing complete thing just by chaining it.
Mm-hmm.
You can see this, for example, with Bitcoin. Bitcoin has some state machine that is like the Bitcoin script that allows you to do some programs. And people say, well, we're like really, really safe here because this is not Turing complete. And you say, well, wait a second. It has a new block every 10 minutes. If I chain one block to another and I'm able to generate a new program every time, out of the blue, I am like unrolling the loops. Boom, there it is. So I think that Wolfram, Stephen is someone I also
Mm-hmm.
respect a lot. And I really like this idea of it's really hard to do something that it's really, really simple. And it's really like there is a big jump. It goes from like, this is really simple to I can do everything. And I think that what we are seeing with AI, it's similar to this. So this idea of, okay, it cannot do these things because it's bounded. And out of the blue, you say like, wait a second, can I make it interact with something and then iterate? And out of the blue, like there is expansion of what it can really, really do. And I think that what I said before about fancy names, it goes in this direction. Like I don't know how I would call this, but I saw how well people did with the RAG thing, RAG, this idea of being able to bring the context and
Mm-hmm.
then they call things like in context learning. So I can wait for someone to put a name on this and
Yeah.
be able to run with the idea.
Yeah. There's a few different examples of this, right? Like, and specifically the looping. I guess I'm on an agent podcast. The agent side of it. One is like, you have someone like Jan LeCun saying, because they're next token predictors, and there's some chance that they make a wrong token at any time, your chances of error go to infinity as you sample longer. If you have any sort of environmental feedback, like detecting that there's a missing import, you can like you can reset that counter, or close those loops, or set that back to zero. And yeah, like with RAG, you can say, oh, there's no way that a single vector embedding is going to capture the nuance that you need to answer a proper research question. And you say, okay, it doesn't, right? It returns me 5 papers, but they're not actually the ones I wanted. But you know what? I could look at the references of those papers, and then I go read those, and then I can look at the references of those papers, and then I can try a new search, and then I can look at those, and so suddenly you've kind of closed this loop somehow. And then any theoretical fancy bounds, you say, look, no RAG system can ever solve this problem. It's like, what if I get to do 2 steps? Okay, how about 5? Yeah, it does change the dynamic a little bit for sure.
Something that I am like kind of sure it's this idea of it's not going to be able to do everything, but I don't know what things I'm going to be able to do that it's not going to be able to replicate. And even for things like, how do they call it, agency now, they say, well, but humans have agency, bots have not. I don't know how well they are going to be able to replicate me in such a way that it looks like, well, but they doesn't have agency. And I say, well, I don't know if I have neither. Like, I feel like I do, but that thing is behaving like exactly as I could. So
Mm-hmm.
let's see how that goes. Those are like funny things that I would always have assumed that are sci-fi in my lifetime, and out of the blue, I am thinking about them in the shower.
Yeah.
So with other things that you have been working on, like this idea of environment and being able to receive, interacting with it and receive feedback,
Mm-hmm.
I think that that's why MCP started taking off. Like it's this idea of, wait a second, it's able to interact with the environment. Like out of the blue, people are freaking out saying like, wow, it can do all these things. This is something that you already thought at Answer.AI and actually like
Mm-hmm.
brought another kind of solution there, called LLMs.txt. Could you give us like a runway about it?
Yeah. Okay. So this general space, yeah. Well, I'll start with LLMs.txt, and then we can expand. So LLMs.txt is a proposal for a format. And the idea is we have these language models, but they have a training cutoff, right? Some are still 2023 or early 2024. So if you take something like FastHTML, which is our web framework, it's not in the training data. And so the language model is going to be severely hampered in trying to help me. And so you could say, well, look, just use a language model with a very long context and put all of the documentation and all of the examples in there. That's one approach, but it's expensive and slow, and the longer the context is, the worse these models do often. So instead, you could say, let me write the perfect tutorial just for the language model. And that's really fun. We're working on a concise guide just for that exact purpose. Let's get 10,000 tokens of beautiful, concise, idiomatic way to do this. But the other way to do it is to acknowledge, like you said, that there's intelligence at the edge, right? So LLMs.txt, the base file isn't all of the documentation. Instead, it's like a short description of what the library is, and then it's a link to lots of other documents, some of which are like quote unquote essential, and some of which are optional. So for FastHTML, it's like, this is what FastHTML is. These are the technologies that it's built on. You probably also want to look at HTMX, which we use with FastHTML. You probably also want to look at, Serial.js and these styling things. And then if you're interested in UI, go read the Monster UI documentation as well. And if you're interested in the backend and Starlet middleware, these are the Starlet docs you should look at. So it's like a list of links. And then up until quite recently, the way to use that was to just populate all of those links, and then you get your big context. But now it's like, hey, we've got language models that go to tool calling, right? We have very simple, like we have a library called Claudette that lets you do a tool loop very easily. Read the LLMs of text, and then tell me which links you'd like to read. It's if I ask you to build me a Monster UI calculator, like, let me read fast HTML. Okay, I want to go and read Monster UI. So, like, pull in the next set of docs. Okay, Monster UI says I should also reference a Tailwind. Okay, let me read the Tailwind classes. Or the language model says, no, I actually know Tailwind. That's fine. So it's a way to like dynamically fill your context with just the pieces that you need. And yeah, it turns out that works really well, right? The competitor is to say, look, just have RAG on chunks of your documents and hope that it pulls in the relevant pieces. And the difference is kind of night and day. When you look at like vector retrieval for my question, similarity to like chunks of pages where you don't even know where that page came from, versus this very like nicely structured, look, here's the description, here's the things that I thought were relevant, and the language model has chosen them. In our case, often like we'll put that back in front of a person to say like, yep, I agree. Let's read those documents. and then together we're looking at the docs, and then we're working on the application. Yeah, so it's a very documentation specific format, but at least until browsing agents could do that perfectly themselves, it seems like a very nice way to manage bringing in the shared context that you need for working on an application.
I love it because it comes from like from first principles, and it kind of matches the flow that humans do. It's like, well, I don't know about this. Let me learn about it, and out of the blue, like I am able to do it. I think that it's like a really, really nice standard, and I hope like it's catching up. There are places like Mintify that already like you have all your docs exposed this way, and I see more and more
Mm.
companies doing it, like from Stripe to like a few sets. So it looks like there is a place in the world for this, and I want it to be used more and more. I'm sure that you can even connect it to MCP and say like, well, this is the MCP for LLM.
Yeah. In fact, I just today, literally like several hours before this podcast, Hamel, so if he hasn't shared it already, he'll share it on his Twitter soon, made a little MCP server that does exactly this. Just brings in LLMs.txt and then asks Anthropic which ones to populate and does that. But also the exact implementation isn't really important, right? Like you can also do this with MCP. You can also do this with a really nice cursor rules, with like lots of markdown documents. And you can also do this with just plain Python, right? If your language model can run Python, it can read URLs and then it can follow links. And the exact approach doesn't matter, but this general idea of like just progressively like browsing and pulling in context that you need, like it's such a useful primitive, and I really hope it catches on more broadly.
I agree exactly with this point of it's not about how it's solved, but it's the right problem to
Mm.
solve. So, like whatever solves that problem, we're happy there. Like it's a big enabler. There is a small difference from what LLM.txt does and what I do or what I see that humans do, that it comes after. So the first time that I encounter a problem, yes, I read the documentation and then somehow it gets impregnated in my memory. So every time when I have to do something, I don't have to bring it. Machines go so fast that maybe we don't need it at the beginning. Like we can say like, well, for the amount of information that we are handling, that it started with the ones that humans did. Like there is
Mhm.
such a difference between what the machine can handle in context and what a human does, that it looks like instant. But even so, I would say like then I want to ask more from the machine. So I want to expand the context to make sure that like I am hitting the limits of the machine. And then this thing that worked for humans, that it's memorization, may start kicking with LLMs. Does Answer AI have any solution for memory? And I am asking this for real because I know that you're so good at what you do that if you have something about memory, I didn't see it and I want to know.
Well, this is going to sound a little cheeky, but like, if only you had a nice dialogue, right, with the history of the problems you'd worked on before, with the inputs and the outputs and the examples and the summaries. If only that was there, right, and you could summarize parts of it. Maybe we have this, maybe we don't. But yeah, it's kind of if you had to make a separate like memory.markdown file and manually manage that, you could do that, right? And I think that's a good idea. And I think actually Claude Code might do this. It writes notes to itself in Claude.md. But if you're in a dialogue, right, or something like a notebook, and you're having these exchanges and you're pulling these documents, somewhat dynamically into context, and then you're summarizing them and writing tutorials, and then you're like, say, okay, you can let go of the full docs, but keep this summary that you wrote. Then you don't have to. It's all in one place. It's not separate. So then you get that basically for free. You have this memory and this history and these past examples of how Johno specifically wants to use this library and what exactly I'm hoping to do with it. Yeah, so.
So that's already like a really good solution. Now, if I have to implement it today, this idea of okay, let's do something. Let's write only the parts that are important,
Mhm.
and then like every time that you do something, you bring it in context the first thing, and it's
And
when it's not there. But how do you think that it works with people? Because with people, like we don't have that other summary, like or it's embedded in our weights somehow, where like it gets fused with the neurons of I already know this. Or do you
it's,
think that there is some kind of pre-processing where it's like, well, there is a documentation that you read today and the documentation that you read before so many times that it kind of brings it there.
if I've done it 100 times, it's embedded in my weights. If I've done it once, it's not. Right? This is why I blog. One of the reasons I blog is because I'll go back. Oh, I wrote a post exporting YouTube videos, getting the metadata. So that's not in my brain, right? But I do have a file on my computer that has it. So yeah, I'd push back. I'd say like the second time we do it, hopefully you're like Simon Willison and you have a GitHub issue that links to the documentation you looked at because I am going to have to read it again. It's only like time 1,000, right? When I'm writing my training loop, then I remember, okay, I don't have to go look up the PyTorch reference. But the first time and the second time and the third time, yeah, I'm looking back at, hey, what was my notebook from last week, right? Where did I do that? So I think even people have that physical artifact, and it's a nice pattern. Even like I'll do this if I'm using a new library. Yeah, I'll take a skim of the docs and then I'll feed the docs into like ChatGPT or whatever, like whatever's easiest, and say, write a tutorial specifically on how to do this, right? So there's this whole library for simulating fluid dynamics and whatever. I say, look, just write a tutorial for everything you need to make a woodwind instrument, right? And then I get one little concise markdown file. I can put that in my notebook as context, but I also just have it like bookmarked. In 2 months' time, I want to come back. I don't have to read the full document. I've got it there.
The bookmark, it's amazing how things like seems like a joke, but it's this idea of in computer science everything can be solved with a layer of indirection. If you just add a layer of indirection and out of the blue, like the problem goes somewhere else. So this is funny because when I heard you saying like how people seem to act, like saying like, well, the first time I just read it, the second time I remember what it is, and you just remember that piece of software. You say like, well, I don't remember the thing, but somehow I have a level of indirection, and it's eventually after you have done it 1,000 times. I think that we may see something with models that start resembling this idea. But again, it may come later because now they are so fast and so capable that it looks like they can do everything. Like nothing that humans have faced until now, it's a challenge for them. So they're like, just bring it in context. Like, give me 1 million tokens. That's nothing for me.
Yeah, I mean, maybe this is, going back to our, like, you should test on dumb models. Like, maybe this is spoiling us, right? Like, oh, if you've got a million tokens of context, you don't have to come up with these other things. Like, continual learning, we don't need that. We'll just have an infinite context window. But maybe it's worth thinking, like, okay, maybe that's a hack, and I'm never going to overcome the fact that I
Yeah.
actually need more than that. So, yeah.
I always try to think from first principles because of these reasons. And like, well, even if you can't solve any problem today, can I think about bigger problems? Like, I am really greedy. Like the bigger you give me the intelligence, the harder things I'm going to ask for it. And it's something funny that I saw with really fast inference with Grok and Cerebras, for example, that people are using it for getting the same thing faster. And I always think like, no, 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 no. I want to do like now that I can do things faster. I want to do what it was not able before. So the example that I always put is this idea of what's the software with more brain power in the world. Maybe it's like Linux. We're having like 15 years there. Okay, I want machines that in one day they're able to put the same level of intelligence in a code base than we had at Linux. Like I don't want to be like the copilot saying like, okay, wow, this is really fast. I understand like this is also like really, really good, no? But I see the other part underexplored. This idea of wow, it goes so fast that now I want to do the things that I wasn't able to. Not the same things faster. So I have a couple of questions and then I will let you go.
Yeah.
And the idea was about what you mentioned already. It was fast HTML. Could you give us I've used it before, but I know that it's new for many people. So what it is and why does it exist?
Sure. So FastHTML is a web application framework that tries to build on the really solid foundations that we already have. So we already have HTTP and all the features of that layer handled. Like we don't need to change that. We already have HTML, which is a very powerful way of creating markup and styling it and so on. So FastHTML uses something called fast tags, which is just a way of writing in Python these objects that map directly, like one-to-one exact mapping onto HTML. So you can create a capital P for paragraph, and that'll map to the HTML P paragraph in the web. But so then FastHTML is like this kind of like upper layer that makes it really easy to work with and construct those tags, to work with and deal with requests and forms and all of those pieces of a web application, right? Defining different routes and different behaviors, storing things in your session, right? Cookies and authentication and all of that. So it's a way for us to build web applications in Python really quickly, really minimally. And if you know how to build for the web, then you can build with fast HTML without much like translation needed. And so yeah, it's built because we're very frustrated. We're like, oh, we want to build thousands of applications and we want to stay a team of about a dozen people. So that doesn't work if every application is constantly like needing to update all of your different, node libraries and manage 1,000 different environments. It'd be ideal if we could build this the same way we build everything else, interactively and iteratively in a notebook. It'd be great if we could build it in Python. It'd be great if LLMs could understand it. So the one-to-one mapping to HTML, it's like these models are smart enough to do that kind of style transfer and to speak it without necessarily much training. But it's also kind of a decision that I'm still curious to see whether it pays off, because I can write things in fast HTML, and historically I didn't really enjoy web development, and now I find it very, very easy, almost trivial to do the the bits that used to be hard. The bits that are still hard is figuring out what looks good, right? So like there's no magic bullet for that. Figuring out what your application should do, like there's no magic bullet for that. Like it's you still need to come up with a good idea. And then also like the interplay of how do language models come into that then? Like you said, these models can make really beautiful web applications by default, but they'll probably use like React and ShadCN or something like that, right? And so we have to wrestle with like the language models know those by default. We have to teach them FastHTML. So we have to use LLMs.txt. We have to use examples and hope that in context learning they pick it up. So there's a trade-off there. I'm still not sure, depending on how good agents get. Maybe that was foolish and we should just always make the visual part of it just by describing. But until that day, if I have to work on the applications, I much prefer working on FastHTML applications because they're short, they're easy to see what's going on. It's very clear how to modify it. It's very pleasant for me to write, and the language models are good enough that they can be helpful.
For anyone listening who hasn't used anything about Answer.AI yet, I think that this is like the right advertisement. Like you mentioned like multiple things, and before you gave the hint of somehow they look like despair, but then like they are aligned with something. I think that any good engineer will understand if we write it this way or describe it this way. I think that what I really like about Answer.AI, it's the idea of you are doing like different tools that do one thing and does it well, kind of the Unix philosophy. And it will be successful for the same reason that Linux was. That it's this idea of, wow, and then if you master those tools, when you put them together, out of the you are like incredibly powerful with your keyboard. And I think that that's, if you look at all the different pieces that the different parts of Answer.ai is doing, seems that it looks like this. Like they are really good at one thing, and somehow they play like a really nice symphony when you put them together. So if anyone has not tried them, please go and check LLM.txt, FastHTML, and solve it, like most of the things that you put out there. And I always like to close with a couple of questions. The first one is, what would you like to see in the next 6 to 9 months in the AI agent area?
I think I'd be really excited if more people invested in the idea of having the human in the loop more creatively. So whether that's like going beyond chat. I love this like where you can zoom in and out on text, right? So you have summaries and then you can expand them and you can expand them. If it's doing tool calling, you can like intervene or tweak or steer or branch. I think there's a lot of like creative ways to have people play with these assistants in really fun ways that are super underexplored. So I'd love to see that kind of avenue. Probably my top
That's a
like
really
hope.
good answer. So this idea of how people interact with AI to be like broader than just text. Okay, like that's a really good one. And what would you like to stop seeing? Like, is there anything that people are doing today with AI that you're like, guys, please don't use it this way, or it's not going to be supposed to use this way? It's already 2025.
I think the sad trend would be if people felt like they actually got disempowered, right? If you just gradually said, "Oh, the language model it does things that I don't understand," and to me that's a user interface failure, right? Because you're hiding it away, and it's in a separate box. You can't see what it's doing. You're pretending code is this magical thing that nobody can learn. If people felt disempowered, then that would be like a really negative outcome for me. And it's like an economically appealing outcome, right? Like, oh, just replace this person with an agent. You know, like I can see the appeal of that, but I hope that over time we keep trending towards like, how do I make this person amazing, right? With my tool, where they feel like, and you see this with people with really good tools. I've never seen a machinist using a CNC machine who feels like I really miss turning the handle on the lathe. You know, it's like, hey, look at the cool parts I get to make now. But they're active in the process. They're problem solving together. They're using the tools. They're like upgrading. Oh, we get this new feature in our CAD. We can do these like 5-dimensional things now. It's really cool. And so if you could take that model and say like, oh yeah, sure, you know, I'm doing a lot more work than I was before, but it's not because I've been replaced. It's because like I have these amazing new technologies that are doing cool things. That's the vector that I hope we move along.
Yeah, and I think that here, people who are not technologists, but people who are like artists, researchers, people who are educators, I think that they have like a really good position to say like, okay, there is all these things happening in technology and the business world that it's mainly like focused on agents that can do what people are doing today. How can we leverage this and give it to people as tools that then like empower what they
And
do?
the tool makers have to show them, right? Like if you say to an artist, hey, look, I made this thing and you push a button and it makes art. What are you saying? You're saying, I don't need you anymore, right? Like, look, I push this button. If you changed your tool and you said, look, like put in your sketch, put in your vision, and then we'll help you make that, right? And then you can paint over it because we have a canvas there. it's just a different conversation. And you can still say, look, maybe I can get something now, whereas I might need to hire a professional before. Like there might still be that aspect to it. But if you're marketing your thing as like, you don't need artists anymore, we've got this, you're missing out on saying like, dang, I'd like to see what the artists can do with that. You know what I mean? Like give them the paintbrushes. Don't just like say, hey, like push this button and pull the slot machine. So I agree that, oh yeah, all these people need to come in, but I don't think
Yeah.
artists and programmers and writers come in. I think the makers of the tools need to change a little bit to say, here's how you can use this positively in your way, rather than like, oh, we don't need you.
Yeah. Well, the point is that we still do. Like, like the world is better the more people there are. So, we want to make sure that we're able to empower whole humanity. Excellent, Jono. So thank you very much for coming. I enjoyed this conversation a lot and looking forward for, the next 6 to 9 months to see how things evolve. And I hope like people start doing more what you said and less what you don't want them to do.
Yeah, cool. Thank you so much, Jody.
Thank you. See you soon. Bye.